What's up, folks? In this video, we're going to talk about how do we go from an LLM like ChatGPT that can generate text all the way up to an agent that can execute actions in our behalf. So it's about how do we, like all the intuitions we need about building agents, starting from the LLM API, right? An API that can generate text. So this is going to be a very intuitive but introductory kind of guide to constructing agents and intelligent systems, but from a very basic perspective. I want to talk about the intuitions and talk a little bit about code in the sense of what are the abstractions we need, etc. Okay? And we're going to talk about text to structure actions and then control. We're going to talk about patterns, workflows. Then we're going to talk about the agentic loop, which is the most important part of this presentation here. And then we're going to talk a little bit about evaluation and a little bit about frameworks. So the core challenge that we're trying to face here is we have right now a model that can take in text and output text, right? If I tell ChatGPT, like in this example here, schedule a meeting with John for tomorrow at 2 p.m., the output of the model is just text. In this case, the model is actually trying to show me, how I would go about this, but it's not actually doing anything, right? And how do we go from here to actual actions, right? So how do we do this bridge where the actual agent starts checking the calendar, sending invites, taking the actions we care about? So the core idea that we start with is this basic idea of a prompt comes into the LLM and an output comes out, right? And for example, write me an email to my manager, and then the output of the LLM is like, Dear Sarah, I hope this email finds you well, tarari, tarara, right? And what are the limitations here? Well, it's kind of obvious. There's no external data access. There's no real-time information. There's no action beyond generation of text, right? And the first innovation that we need to understand in order to start picking up, like how is it that we have agents now that can do stuff? And I think the first one is function calling, right? The ability to have LLMs somehow call functions. And when I say function, I mean a Python function, like, calculate the sum of two numbers, or a JavaScript function, whatever, function written in code, okay? And this innovation, I think that one of the most important papers to understand this is called Toolformer, which I have it over here. It's called Toolformer, Language Models Can Teach Themselves to Use Tools. And a really cool thing that they did on this paper is that essentially they show that you could prompt the model to have an output, which I have like highlighted here. And I don't have it, like this is from their original paper. We can have a model that output text where inside the text, there's a part of it, in this case here under brackets, that can be parsed into an action, right? You can have some code that will look at what the LLM puts out, and it will parse whatever action is in there and remove and take that action and do something with it. To demonstrate this idea, I'm just gonna open up here. We're gonna have a little notebook here just to demonstrate this idea, all right? So to demonstrate this idea, what I'm going to do is I'm going to import from OpenAI. Okay. Let me set up my kernel and Python environments. There you go. And then I'm going to set up my client with OpenAI. And here we're going to say, okay, response is equal to client.chat.completions.create. And I'm going to use GPT-4o as my model. Okay. And I'm going to say messages. And the prompt that I'm going to send to this model is going to be this, okay? Imagine you have access to a calculator function called calculate. If the user asks something about calculating the sum of two numbers, let me just put this here like this. There we go here, we'll do it like this, sum of two numbers. You will output a string where inside, in the right place, there should be, this prompt is getting kind of big, a function call. There you go. I think cursor helped me a little bit here. Function call to the calculate function. And then let's create an example. For example, for example, I'm gonna do like this. All right, perfect. For example, yeah, and then we're gonna put it like this, and beautiful, for example. And let's put it like this. I think cursor can help me. The result of true plus true is, and then we're gonna put it like calculate. There you go. And yeah, it's let's call it calculate sum instead. There you go. Okay. So I think with this is already enough, all right? And I'm not even putting this in the system prompt. This is just a very silly example, okay? So user. And now I'm gonna put here in my prompt, what is 5 plus 5, okay? So I'm gonna put this in there. And now let's see what the output is, okay? And I'm gonna say output instead of agent here. And let's see what happens. So now let's see what happens. I'm gonna send that out. I have to set up my kernel correctly. So 1 second, folks. Kernel automation, kernel automations. And there we go, we're sending that out. Nice, all right, folks. So here we go. We get this output, which I'm actually going to save. So parsable, I'm gonna call this parsable output, okay? Parsable output. And now I'm gonna send that out. Beautiful. So folks, check this out. Now I'm going to parse this parse output. And here is a very silly example. And I don't like this example. Calculate sum dot split. Let's shoot yeah, 0. Split, it's not getting the here. I'm just gonna, let's just change this to be like parse and return all text within brackets. Okay, perfect. Nice. So folks, as you can see, when we take the output from the LLM, I can parse the function called calculate sum, right? And imagine, folks, if I wrote this function here, calculate sum, A and B, right? And I can say return A plus B. This is like the most ridiculous example, right? Calculate sum, now check this out. I can transform the string into something, into actual execution of code inside of my notebook here. And because I have the function defined, I can actually get a result. So if I do something like eval, parsable all, parse the output, and then parse, check this out, folks. We get the result. We get 5 plus 5 is equal to 10. So we actually get the execution of the function call from an output that was generated by the LLM. So the LLM commanded this idea. So imagine if we wanted to incorporate this into the function that we were using here in the code, folks, we could actually set up a little we could actually set up a little function. So I could come here and I could say something like I could say user question. There you go. So now let's wrap it into a function, including the parse output stuff. So let's have cursor help me out a little bit. Beautiful. So now we have this function here. We have model. We have this. And I'm not even going to do anything fancy with this. All right, folks? I'm going to just move this function parse output over here. Yeah, parse output, calculate function. So now we have inside of the function all the actions, folks, required to actually do everything that we need. We take the output, so we say parse the output is equal to this, and now we can say, okay, let's see, the parsed output is going to be returned, and now if I call this function again, now I can say, I can have a user question, right? So get calculated response. So I'm going to say get calculated response, and I'm going to send a question that it's improper. what is 10 plus 10? Please provide user question. I'll be happy to da-da-da-da-da. Yeah, because I didn't put a net string here, folks, but now I did. Okay, so now as you can see, the parsed output is coming as calculate the sum 10 plus 10. So we're getting the indication that was provided to us by the model, and then we just use this function parse output that we wrote to parse it. And now we can execute it separately and then include it in the output of the model, right? So I could come here and I could actually include this logic over here. I could say, okay, I'm going to take the parsable output and I'm going to say, okay, parsable output dot replace, and I'm going to replace whatever is in, and we're going to say da-da-da-da-da. We're gonna replace whatever comes out of that model with this parsed output. Okay? So we could do this in two function calls, or we could just take the response and replace that information from the model into that output. So what I mean by that is I can return parsable output and the parsed output. Imagine this. And now when we get a result, we get this is the thing and this is the parsed function. So I could execute this part and then replace it over here, and we would be essentially doing the same thing. The model would have indicated they wanted to call this function, and we would have just done the job of doing that for it, and we're done. So that's function calling in a nutshell, folks, in the most rudimentary way possible, right? We're not accounting for the fact that the model can sometimes add things that we don't want to the string and do other stuff. We're just looking at the basic idea of just having the model return something where inside there's something we can parse and then execute that function on the side and then maybe include that in the result of the model. Okay? So the idea that they innovated with in this paper is that the LLMs can learn to suggest tool usage by generating these special markers, or like by having, you create a data set and show a bunch of examples to the model, how we want responses to be organized. And this is a really clever way to get the model to perform actions in a way. Okay, so like in this example here, what's the weather in San Francisco? Weather is la 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 la, and the API call to the weather function is within these brackets over here. Okay. So the process is to generate text with these API call markers. The system, like I was showing in the Jupyter Notebook, parses and executes the function, and then the result gets fed back to the LLM, and then the LLM incorporates the result into the response, okay? So I could easily just place this, put it, and call the LLM again. You get the point, right? So this is really cool. This is really cool. This was one of the first innovations that opened people's eyes to the fact that these LLMs can actually guide and control execution of actions indirectly, right? It's not the direct execution. It's not the LLM wasn't trained in a special way to have these actions be part of its functioning, but we can have the model with some clever hacky tricks execute actions. Now, the other thing that we need is a little bit more structure, right? Because imagine, outputting calculate the sum of two numbers. That's a little bit tricky and risky, right? Imagine if I used probably GPT-4o Mini or a local model, maybe we would get extra things and not just the calculate sum call here, or the model could change the name. There's a bunch of stuff that can happen. We would like a little bit more control over this process of calling functions. So what if we used something called Pydantic, folks, which is a data validation library in Python. And we created a class called calculator parameters, okay? And we call it, and now in this calculator parameters, we have the first number and then the second number, right? Something simple, which is the two numbers to be, that should be summed together for some function. So now, what we would do here, in order to, how would this thing work? So what we can do using the ChatGPT API, which I'm going to pull up my little snippet here, and I'm going to use GPT-4o for that. And I'm going to say, you are a helpful assistant. that helps users with calculations. Okay, that's all I'm gonna say. But I'm gonna add a little special thing here. I'm gonna say response format is equal to calculated parameters. Now, we haven't talked about what this is yet, but what's going on is I'm enforcing an output with a specific structure using the OpenAI API by saying that the response format should have the face of this data structure that we indicated over here. All right, that's what we're doing. So now check this out. If I come over here and I say get, and I'm not going to call this function get response, I'm going to say get structured response or something like that. And now if I say get structured response, what is 10 plus 10? Check this out, folks. I have to do a little bit of there's just one thing here that we're going to have to do. Client.beta.shadow.completion.parse, and then it's message.parsed. But now check out the output, folks. The output, it's not going to be anymore text and some complicated things. It's going to be a structured object, something that we can access its attributes in order to obtain exactly what we want. So we're not depending on the LLM generating the text with the right things in the right place. Now we're generating something that's easy to extract. Because now I could say something like output struct is equal to this, and I could access individually A and B, right? So if I say print this, or we can print all the numbers, or we can say something like, A equal to this, B equal to that. There you go. So now the output looks nice, beautiful, great. So this is really cool. So the idea here is that the output, we're enforcing a structure for the output that we get from the model, okay? So the problem was that LLMs express intent in a bunch of ways, right? And handling strings is tough. Parsing text is hard, it's annoying, a lot of weird things can happen. So, sometimes you can get all sorts of annoying issues in strings and quotes and double quotes, etc. So the solution that was found was to have an output that's a JSON or a structured output that can work as a payload for the function. Meaning, output's a dictionary with the right keys where we can access the values of those keys and then send that to a function. So check this out, folks. If we go back here, now what we can do is we can say, okay, so we have the output struct, right? So now I could say something like A is equal to this, B is equal to that. And I'm going to say a var just for the sake. And now I can do the call of the calculate sum, and we get the response. So you start seeing what kind of stuff can be done when we have this ability to output something in a structured format. So this is pretty cool, right? And there's a bunch of different techniques and ways that people got to this. Initially, I think it was through prompting the model in a specific way so that the output would have a certain structure. Just like you can output with ChatGPT something in bullet points, you can have the model output something like a Python list and things like that. But then they started training and fine-tuning these models to output perfect JSON. Okay, and there's a bunch of other interesting techniques, but the basic idea is extracting structured outputs, right? Dictionary keys and values from an LLM call, all right? So before we had that prompt goes in, LLM, and then the output comes out and the output is a string, right? Now, if we send a prompt to the model, like what's the weather in Lisbon? The LLM is gonna say the weather is blah, blah, blah. So that doesn't really work. So what works now here's where we are in this discussion of actions and LLMs, etc., is that an input comes in, like what's the weather in Lisbon? And the output of the model is going to be a dictionary containing an indication of what function should be used and what are the parameters that this function should use. Okay, so in this case, like location, units, and in the case of the example I was showing in Jupyter Notebooks, it was like the two numbers that should be summed together. Okay? So just a demo function call mock, just a call mock example here in code so that we kind of keep that idea in mind. So imagine that the output was this, right? The function is this, and then the parameters is this, and then the expression. This is like a mock example. Imagine that this was the thing. So we have here a function that essentially evaluates the expression that comes in. Please imagine if I copy this little function, this expression here, if I say eval and I put this under string, we get the actual sum of that, okay? Because this is something that can be directly executed if we call this in Python eval, and there's a few different ways to do this stuff. The point is we can turn this into action and into code and execute it immediately, right? And that's what this example here is showing. We can execute this structured output that we get from the model. And I did a different example over here where I obtained it with the data structure that we created here. And then we use the calculate sum function to just run the sum, right? So similar idea, similar examples. Key insight is that structure outputs bridge the gap between the reasoning of the LLM and deterministic function execution, right? The LLM can output text and it's a probabilistic situation. So the output might be right, might be what we want, might not be what we want. But we can enforce structure in the output of the model, and then we write the functions ourselves and make the situation a little bit more deterministic, right? So first idea, I hope it's clear so far, right? We've talked about function calling with hacks, right? The model outputs something that we can parse and then execute. And then structure outputs adds a little bit more structure and rigidity and determinism to the situation. Now, we're still not perfect to get to actions and autonomy and control. Because function calling, this idea alone is not enough, right? We need a bunch of stuff around it. We need to take the function calls from the output, like we were doing before, and then we need to actually run these functions. And then we need to handle potential errors that might occur. And then we need to integrate the results like we were doing in here, in this example over here, folks, when I was integrating the parsed output, and we kind of did it halfway just to demonstrate this idea, right? We take the output and then we parse it, integrate into result, and the idea was that we could send this back to the LLM and say, look, the user asked this, this is the result of calculating the function, give a result to the user, something like that, right? So here's the situation that we're in right now with the current version of our thinking, okay? So what's the weather in Lisbon? This input text comes in and it goes to the LLM. The LLM outputs something that's a structure that can be parsed into something, right? So this is like the payload for the function get weather, where we can take the location and the unit. This is one example of the function execution. And then if there's a problem, we send that back to the model, right? If there's no problem, the result gets sent back to the user, which is what I was demonstrating here. And when I say problem in this case here, errors, I don't mean just code errors, but like maybe the calling the getWeather function returns some other type of information, whatever it is, we send that back to the model. Now, there's one thing that might be a little bit confusing. When I say no, we send that back to the LLM. Actually, if there's no problem calling this function, the output usually goes back to the LLM itself and then goes back to the user. But that depends if the user just wants the response, that we could do it directly. The point is we're halfway done with giving LLMs the ability to act autonomously. So just to summarize so far in a mock code example, imagine we have now, we can start seeing how this takes shape, right? Imagine you have now a big dictionary that has actions for getting the weather, getting the time, sending emails, okay? And each of these is, these are just mock examples, okay, folks? And then imagine you get an output from the model that has this structure. The reasoning was this, and then the function call, and then the name, and then the arguments for the function. Now we can, and this is when we execute the function call, we can get the function that's supposed to be executed because the LLM is going to indicate that information in its output. We can take the arguments and then we can execute it because we have a dictionary that can map a function name to the right function. In this case, it just maps to these silly temporary lambda functions here. In this function example, actually, lambda cinema, actually, Yeah, because these examples, folks, essentially what would happen here is that we would pretty much just return these mock, we're just returning mock examples. We're returning things that are just for demonstration purposes. We're not actually doing anything with the inputs. But this just to demonstrate the idea of how we can start piecing together this architecture of giving LLMs the ability to act in our behalf. Okay, so next level of this, how do we go from here to the next level? So for that, we need to make some considerations about the control flow situation that we're in, right? Now, we need to consider synchronous versus asynchronous, because two calls can be slow. So sometimes it's nice if we can do things in parallel and so on. We need to be able to recover from errors like invalid parameters if the LLM makes a mistake, etc. Failures with the API if the LLM checks the weather API, but the weather API is not working for some reason. Security issues, right? Because function calls can be very dangerous, folks. Like I was demonstrating these silly examples with Python, but imagine if a function call is about authentication, or is about anything related to security information or personal information. So if the LLM has the ability to call functions that do things that might put people's data into risk, for example, that's a problem. So we need to address that. We need to manage the context for the model, right? So how much history we can maintain so that the model can structure complex actions and so on, but at the same time, we don't spend too much in tokens and things like that. So we need to consider those things. We also need to consider situations where if we put the ability of the model to take actions, but we put that in a loop, we need to be able to say, look, this is the condition where this loop stops because the action is done or because the situation is done. So we need to consider how we're going to end this loop. But I know this might be a little bit too abstract for where we are right now in this discussion, okay? What we have right now is the ability to take an output from the model and then transform that into an execution of a function, okay? So what is the next level to get to agents? And for that, folks, I'm going to ask you to go check out an amazing article by Anthropic. And I think it's becoming kind of like a reference point for a lot of people that work in AI engineering, and it's called Building Effective Agents. And what this article showed, which is I think is awesome, they showed it in a really intuitive way that all the basics of the patterns and ways of piecing together LLM applications from a simple LLM that has access to functions, they call the augmented LLM, right? All the way up to agents and when you should build agents versus when you should do something else. Really cool article, go check it out. So let's explore patterns that are simpler than agents that make like a bridge, that build our path towards an agentic loop. So check out this article, and there's this quote that I really like. We recommend finding the simplest solution possible and only increasing complexity when needed. This is key, folks. Why? Because one of the problems with today's hype around AI agents is that people start doing this thing where instead of having a problem and solving the problem, people start from the tool and they want to find problems that fit the tool. And we should never do that. We should always do the opposite. We should always start with the problem and find the tool that fits the problem. So for that, we need to start with the simplest solution possible and only evolve in the complexity of the solution if the problem requires that kind of evolution, that kind of complex evolution, etc. So in this awesome article that I recommend you check out, they make this distinction between workflows and agents, right? A workflow would be a predefined code path with LLMs and tools. And an agent would be when the LLM is dynamically controlling the process of an application, okay? So to give that idea, I have this big diagram here that I generated, but I want to show something a little bit simpler first. So check this out. I'm going to open up my Scally Draw, and here let's show a few examples of simpler patterns, right? For example, in this pattern over here, right, we have a simple chaining pattern, okay? So this is called a chaining pattern. And what this pattern is doing, folks, here, is essentially this. Check it out. We take an input text from the model, right? And we send that to, I mean, it can be whatever. It can be GPT-4o, it can be, Claude, etc. So then the output of the model somehow goes through some code. So this that I'm representing under gate here is like some Python code, some Python, JS, whatever code, okay? And what's going on in this gate is that we're just checking to see if the output of the model perhaps has the information that we wanted, passes some condition, some checking condition. If it does, it goes to another model. So it goes to the next model. And then it might potentially go to another model, etc. The idea, and if not, it fails, right? But the idea is not this gate. The idea that I want you to pay attention is that we're chaining together calls to LLM APIs. That's why it's called a chaining pattern, because it's one output goes to another model, goes to another model. To demonstrate that, let's just do like a silly example, okay? So I'm gonna say prompt 1 is equal to write a 1 paragraph about how the philosophy of software engineering, of efficient, I don't know, I'm making something up, right, folks? So I'm gonna send that to a model. So I'm gonna pull up my ChatGPT code here. I'm gonna put GPT-4o, and I'm going to save this underneath here, and then I'm gonna get a response, okay? And I'm gonna call this first response that we get, I'm gonna call that output 1, okay? Print output 1, perfect. So let's first run this, and let's see what we get. So I'm gonna wait, there you go. We get philosophy, software, efficient engineering, nice. And now I'm gonna create another prompt. I'm gonna say prompt 2 is equal to organize this text into bullet points, okay? The output 2. However, this prompt number 2 is going to contain output 1, okay? And this is important because now, folks, when I'm sending prompt number 2 to the model is going to see the output from the first call that we made. So we're chaining together because the output of one call goes as input to the other call. And we could do this in many different ways. I mean, here I'm writing a new prompt that processes the output of the other one. But we could just have this in the system message and then just have the model process it. There's a bunch of ways to do it. The point is we're chaining together prompts. So now we can send that out, and now we got we created the first paragraph about philosophy of software engineering, and now this output makes bullet points, right? And we could do this, and maybe the next one will be summarizing this, extracting keywords, whatever it is. The point is we're chaining together prompts, okay? So this is great. So this is a simple example that we're calling prompt chain over here, okay? And the simplest example is actually just sending one prompt, which is kind of obvious. And we're showing chaining, which is this example over here. Now, the next one that I want to quickly cover, and I'm not going to cover all of the patterns that are discussed in this awesome article by Anthropic. I'm just going to cover the ones that I think are relevant for our little discussion here. And this router pattern is actually fascinating. What the router pattern shows us is this. Let me just demonstrate this idea here. So we have the input coming in, right? And what we're doing here, we're saying, look, an LLM is going to take in some input and it's going to route its output to one of these LLMs, or these would not have to be necessary LLMs. We could have something here that is, instead of being an LLM, it would be like a Python function. It could be whatever we wanted, right? I'm going to put this in red, in yellow, just to demonstrate the difference. It doesn't matter. It doesn't necessarily has to be LLM calls. The point is, the LLM is acting as a router to, given some situation, it will route to something else in our pipeline. To demonstrate this simple idea, I could take this and I could say router pattern, and I would say, check this out. You take in inputs from the user, you take in questions from the user, and you output a single word classifying their topic within. Then I'm going to give 3 options to the model, okay? We're going to say software engineering, let's say software engineering, math, or literature, okay? These are the 3 options. Your output should only be one of these 3 categorizations, okay? So let's try that. So I'm going to call this the router pattern prompt. That's a terrible name, but we're going to try it out. So we're going to try router pattern prompt, and then print, okay. And now I'm going to give, so user, yeah, and then let's save it like this, and then output, and let's see what we get. And now the user question is going to be, what is a hash in code, or something like that, okay? And now we got an error because f string, f something, literal, let's just do it like this. Go. You don't need this, don't need this, don't need that. I don't know why I insist on doing it like that. There you go. So folks, what's cool is that imagine now we could have a router function that takes in the LLM output, okay? And if it's an LLM output, if it's software engineering, maybe it sends to, we could just say the LLM categorized it as software engineering, and then the other outputs. We're just demonstrating this idea where we could have a Python function that essentially is built on top of this output from the LLM to take this categorization and send it to somewhere else. This could be an output to an LLM that has a certain profile. For example, we could have an LLM that specialized in software engineering problems, another that specialized in something else, and so on and so forth, okay? Which is super powerful, folks. So this pattern is super powerful. I think it's one of the most common ones because you can do a lot of stuff if you combine, for example, folks, the way I was doing here was very silly, right? It was just like a simple prompt to demonstrate this idea, and it kind of worked okay. But we could have used structured outputs, right? I could have said something like class router categories, and then I could say base model, and then I could say category, and then the category would be category question between software engineering, math, and literature. So there you go. If I send that to the model, we could get this information like we were doing before. So we could do this in many different ways, but the point is that we can have an LLM as the center of this routing function, this routing capability. Great. So coming back, there's a bunch of other, like orchestrator, parallelization, there's a bunch of other examples, but I hope that right now you get the point that, okay, these LLMs can call functions. There's this thing of structured outputs that allows us to enforce structure in the output of the LLM, which gives us more control and more determinism in our workflow. And we don't have to go to an agent that autonomously does stuff. We can route information. We can chain prompts between LLMs to solve tasks. So we've talked about chaining, which is about sequential task decomposition, right? Like, for example, you can take a voice memo input, and then I send that to Whisper, and then we use an LLM to extract the key intent, and then draft an email, and then polish the email. This can be a chain of prompts to an LLM, right? And you use chaining usually when tasks can be decomposed into fixed sequential steps. And then there's parallelization, which is about taking an input, and then you have the same prompt be used across inputs, right? So you break a task into independent parts, and these parts can be run simultaneously, okay? For example, I have a script. Let me just see if I have my script here. There you go. I have the script that I use for YouTube, folks, which essentially does this. It takes the input from my clipboard, and then it uses this prompt to take the video transcription containing timestamps for the video I just recorded. Like, I'm going to do this with this video that I'm going to be publishing to YouTube. And I take another prompt that's about writing the chapter section for a YouTube video. For example, if we go here to one of my YouTube videos in my channel, and I open that up, let's take whatever example. There you go. And this, folks, this little description and these chapters are generated with this parallel pattern that essentially I generate this with one prompt, and then I generate this with another prompt, and then I put them together. And when I'm putting them together, that is called the aggregator. So if we go here to my code, I get these two responses. Folks, it's important to know that in this case, I'm not doing things in parallel, okay? I'm doing this one after the other, but this is an example of a situation where I could have this run in parallel, okay? But the core idea, actually, if I wanted to be more efficient, I could have run these two prompts in parallel with an LMPI, and then I put them together, aggregate the result into something. And the aggregator doesn't have to be an LLM, it can be just code like in this example, all right? And this is an example I like because it demonstrates that you don't necessarily need anything super fancy when you want to do a few simple workflows and automations, okay? And you can also use it for code review and so on when you have independent subtasks or you need multiple perspectives. And routing, we've talked about it, and we actually saw in the Jupyter Notebook the routing function example. And in this example, there's this mock code of a function called classify intent. And then we take, and the intent can be refund, technical support, general question. You can use these in many different ways, okay? And there's a bunch of benefits. Obviously, we already kind of understand a little bit of the intuition. So separation of concerns, you can have specialized prompts per category. Like I was discussing, that we could have routed from the LLM, we could route this to a software engineer LLM or to a philosopher LLM, whatever it is. And then we can optimize cost by routing small tasks to local models, which could be interesting. And there's another mock example here where we have this classify intent function, but folks, in this example, this is just a mock example, so there's no LLM working because we're just demonstrating the idea, and then the router handles the information, and then we have some handlers inside of this little dictionary that can, take in the request and do what's needed. This is great, folks. At this point, we understand a little bit about LLMs generating text. We went to function crawling, parsing, structured outputs, starting to take actions, integrate the results of these functions back into the LLM so that the LLM can produce a decent response. We saw a few examples of patterns for working with LLMs thanks to this awesome article by Anthropic called Building Effective Agents, right? And we talked a little bit about some of these patterns like chaining, router, a little bit of parallelization. I showed a few examples. This is great. But finally, we can talk about agents. How do they work? What's going on with them? What's up with agents? And here's the thing. We need agents when we have open-ended problems, when we have an unpredictable number of steps, or when we have a situation where dynamic decision-making is required, okay? So tasks that require a lot of reasoning and a lot of adaptation. And what I want to do, just to demonstrate this idea, is I want to go here to Claude Desktop. Because in Claude Desktop, folks, I have access to, I have Claude Desktop with an MCP, with a few MCP tools that can do stuff in my computer and that can do different things. So here's what I'm going to do. I'm going to say, I'm working on a presentation about agentic loops. Can you write a simple 3-paragraph explanation about how agentic loops work and show that with some Python code that is actually executable? You can use the Anthropic API, winky face, because this is Claude from Anthropic. Okay, so folks, what I'm hoping that this thing's going to do is actually perform these actions that I'm asking. And I'm going to actually refer to the path where I am in my computer. I'm going to paste this here, save it, save that markdown here, and save the Python function code in a separate file in the same folder. So folks, as you can see, this request that I'm making to Claude is quite complex, right? So it has to understand that I'm working on this presentation. It has to write something, save it to my machine, understand that it has to save to this folder, and then write another thing, save it to the same folder. It's a lot of stuff. Let's see what happens. So now I'm going to send it. And okay, so we see that the write file function is being used to write a file to a specific location in my computer. Great. We can see that the model wrote a markdown file and now it's writing a Python file to my computer. Pretty cool. While we wait for the model to end, we can actually check. And there you go, agentic loop explanation and agentic loop demo.py. So the files were saved, folks. So this is awesome. And then to run the code, set up your Anthropic API key. Okay, this is interesting. So let's see, agentic loop demo.py. Okay, so this is pretty cool. Folks, I'm going to try this because I'm curious to see if this is actually going to work. But what matters, folks, is not that the code works. What matters is that this agent that we just created just did something really cool. So we have now this little agentic loop explanation in 3 paragraphs. We got it saved to the right place. It generated some executable code. It got it saved to the same place. And I could test this code, and maybe I'll test it later, but the point is, folks, this was a open-ended problem. This is not something that I would like to have a specific workflow that works in a specific way for this task, right? It had a kind of unpredictable number of steps in a way, and it required a little bit of dynamic decision-making, right? So another example scenarios would be research this topic and write a comprehensive report, or debug this code base and fix all the issues, or plan and book a complete vacation. So the trade-offs would be higher cost because you're using agents so they can fall into these loops forever. There's potential for errors that are not as controllable as they are when we're working with patterns like we were discussing before. And there's a need for robust stopping conditions, right? So that there's no problem when we're looping over and over. So to really introduce one of the core papers behind this modern idea of this agent loop, which is actually a very specific type of agent loop we're going to talk about, which is called the React agent loop, which is a homage to this paper called React. And this paper was really fascinating. What they saw, what they demonstrated is that you can prompt LLMs to interleave thoughts and actions. You could explain to them, look, the way I want you to output stuff is to think about what you're going to do, and then output the action, and then output the action will have an observation. Well, we have like some result. And then we're going to go into this loop forever until we get to the result that we need. So as you can see here in the React prompting style here, the outputs of the models would be okay, I need to search Apple Remote. And then the act 1 would be this search action. And then in observation, it would be the result of the action that was generated over here. So they saw that you could prompt these models to interleave prompts and actions, to interleave thoughts and actions. So a core example idea would be, I'd structure the core prompting strategy here of the React paper. I need to find information about X, search the topic X, and then found these results, which is the results from this search, and then another thought. This gives me partial information. I need more details about something, and then the action is taken. Search this. Then observation is generated, found additional details, which is the output of this. And then we go on and on until we get to the result. So the key components are the thoughts, which is this planning that is happening in real time. The action, which is using these tools to produce outputs that can be integrated to the model so that the model can do something from that output. And then the observation, right? The results from the actions that are integrated so we can go on and on. So one example from the original paper is the question is, what other device can control the program Apple Remote was originally designed for? And then the thought is I need to search Apple Remote and find program which originally designed to control. And then we do the search, and then the output is introduced. So as you can see, interleaving thoughts, actions, observations. So this paper inaugurated this idea of, okay, let's put this agent in a loop of doing something, observing what happened, and then learning from that to evolve in resolving a task. Super simple, and yet it works amazingly well. So some of the core components that we need to keep in mind. The LLM, which is at the center of this, reasoning and deciding. The tool abstraction, which is the clean interface to external functions. The reasoning loop, which is called react or similar pattern. The stopping condition, because we need to be able to say, okay, we're done, the task is solved, in case the LLM doesn't detect that the task is solved. And then we also need to maintain the state of the conversation in case we need to give more input to the LLM and so on, and handle errors. So the React agent loop would look something like this, right? The user sends a prompt to the LLM. The LLM then will either take an action, which is using one of many tools that the agent's going to have access to, like search, Wikipedia, archive, using the browser, calendar, email, etc. Or it's going to return an output, a final output to the user, right? It's one of those two. So if it takes an action, an observation is produced, which is the output of an action. That goes back into the LLM to integrate and go into the next decision cycle, let's call it. So a mock example is this code that I wrote here. Is just a mock example of what that agent would look like implemented in Python code, just the core abstraction of it, right? We start from an initial query and the maximum number of iterations that this agent can go into. Remember, folks, we need to control for infinite loops, which is like a big problem that happened at the beginning when we introduced agents, which is they would get stuck into these loops forever. So action, observation, output. And then what we do is, okay, we start with this initial query, and then we count the iterations. And then while true, we check the iteration count, and then we will get some response from the LLM, and then we count like, we do an iteration count with this counter here. And then and now folks, this is response type. What I'm representing here is that the output of the LLM is going to be some JSON output, inside of which we have useful attributes like type, where we could say final answer, right? So if the LLM could potentially generate a structured output, inside of which it could have this type attribute where we can parse and see if it says final answer. If it does, we return the final result to the user. So that would be this idea here, right? Returning final result because we detected that the final answer is detected. And this would be an example of the stopping condition we were talking about before. And then if the model does the tool call, which would be to take one of these actions that we're talking about here, then what would happen is we execute the tool, we append the output to the context of the model, and then this is handling the error in case there's something wrong with calling this tool. And if the type of response is thought, the model is actually planning on what's going to happen, that is appended to the context because when it goes to another cycle, it needs to know that the previous thought was to perhaps, I need to reflect on whatever it is. Finally, if we go through all these iterations and we still haven't reached a final response, then we return just unexpected response time, blah, 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 something to handle errors. The point is, it's a while loop that handles the different situations that can happen in this little scenario that we build up over here, all right? So there's a bunch of problems, right? I think an infinite loop is one of them, right? Determining when the agent can determine completion. So if you've used LangChain in the beginning, when they created the framework, they would have these, they're still used, but I think we don't interact with them as developers anymore, but they would have these classes to represent finishing of an action and et cetera. But if you're on a higher level, you don't interact with these objects. The point is we need something to determine stopping conditions so we avoid infinite loops. We also need to avoid tool misuse, right? Which is calling wrong functions repeatedly. So we need to somehow deal with what if it takes an action, but the action is wrong. It's not the right tool to call. If I ask ChatGPT, send an email to my mom, and he actually checks my calendar for events in Berlin, where I'm staying this week for a conference. That kind of stuff can happen, right? And there's also go drift. So if the model goes into a really long problem, task, etc., it can forget about the original goal. And there's also resource exhaustion, which is making too many API calls. It's a little bit more, just to give a bunch of different simple examples. So we need clear stopping conditions. We need to monitor. We need to have cost limits, and we need to have human-in-the-loop checkpoints. Those are not the only solutions, but the point is that I'm trying to make is we now have a good representation of this agentic loop scenario, right? And I generated a mock example here of a calendar email agent that would have access to like calendar, email, sending email, and then you would loop, you get a response, and then if we get to stop, it would return the response. This is just a silly example, folks, for you to get a sense in your mind of like what it would look like to have an agent implemented from scratch, right? And then we have to parse tool calls, etc. In practice, we would have to have much more code, handling errors, validation. There's a bunch of stuff going on. So that's why we tend to use frameworks that facilitate a little bit for us, and we don't have to deal with those annoying abstractions that are just boilerplate and things like that, right? And there's so many interesting frameworks to choose from. Now, before we wrap up, I want to just make a few comments on evaluation. Just because it's not that easy that you just give a task to the agent and we're done, okay? And why is it hard? Because tasks are subjective. So how are we going to track accuracy of, using, the calendar and my email to draft an email to my boss? It's complicated because we have to evaluate the quality of the email that was written and if it checked the calendar for the correct thing. So tasks can be subjective, and it's hard to measure progress in subjective tasks. That's a hard problem. There are no clear metrics. They're just proxies, usually. Like, for example, one proxy is to see for certain tasks if the agent used the correct tools, because we can have a simple data set of a task. For example, I could come over here, let's say, and I could say, like example, so I would say input and tool to use. So check my calendar, it would use the calendar tool. Send email, it will use the email tool. So what I'm showing here, folks, is that we could easily take this silly data set and use it to quantify for simple tasks or for semi-simple tasks if it was using the correct tools for the job. So check my calendar for events for today and send me an email with the summary. So that would be calendar tool, right? And email tool. So this is one example, but there's a bunch of things that we can do to measure proxy of progress when we're working with agents. There's also, it's very hard to measure correctness and efficiency. And there's so many things that you can do. There's one really interesting article by Anthropic. I mean, they write really cool stuff. Anthropic evaluation, creating strong empirical evaluation. And I really like it because, especially because of this little diagram that we have over here. And essentially, obviously, there's a bunch of fancy things you can do, folks, but I think at the core in your mind should be that you should have test cases for whatever you're working on. And then you start with your prompt for your agent, etc. And then you test against the cases that you have. And I'm actually doing this for a client I have from San Francisco, where I'm working through this complex agent that involves integration of many tools, but I'm building my own set of test cases with the help of this client that gives me a bunch of examples of situations that it wants this agent to be able to handle, so that I can evaluate and make sure that this agent can handle them correctly, right? And then we refine it. So these are the evals, and then we test against evals that we don't usually test during this process of refining the prompt. And this idea is just to see if the prompt that we reach here generalizes to examples that it hasn't seen before. This is one simple example to evaluate in prompts, but there's like a bunch of other scenarios for more specific situations, and they do show a bunch of other examples. So it's a really cool article to check out if you want. So it's all about continuous improvement at this point, okay? And there's a few notes on some practical evaluation strategies for test the composition. Break complex tests into measurable parts. So if you're gonna do summarization, did it fetch the right information to summarize? Did it extract the key points? And even better than this, folks, you can check out a GEval summary score, I think, from Microsoft GitHub. So there's really like something really interesting about, there's this paper called GEval NLG evaluation, and I think Microsoft had a really cool, there's a bunch of fancy ways to evaluate, but just to give you a sense, there's this really cool notebook. And they talk about this approach to evaluate summaries, for example. And they go into these steps of read the information and then go through evaluation criteria, compose your reasoning for each criteria. Great. And what is the criteria? And then the criteria is right here, I think. Let's just go down. I think is additive criteria. You're an expert evaluating. They're using evaluation criteria, evaluation steps. Okay, perfect. Where is the actual criteria? At one point, if address all key elements, at a final point. Okay, so in this example, they're doing context. Award a point if the answer uses only information provided in the context without introducing external details. Completeness, add a point if the answer addresses all key elements based on available context without omissions. And conciseness, add a point if it uses the fewest words possible to address the question and avoids redundancy. There's also measuring it in terms of fluency, coherence, completeness, etc. So, and that's just for summarization. That's just for summarization. But the point is, you break down whatever big task you have for your agent into parts that you can measure progress against. Okay, this is a good way to evolve your agents. And this is a little mock-up code example of doing this type of evaluation, where I'm just working on if they're missing tools in the output or if it's using unnecessary tools, and then we're calculating a score. This is one simple example for the specific problem of tool usage verification, but you can do that across a whole bunch of stuff, okay? So I think the most important thing is to have your own vibe check data set, folks, which is like, as the Anthropic article was talking about, set up your own eval test cases and so on. Have your set of things that this agent has to be able to do, because even though there are many benchmarks, okay, for example, there's the Gaia benchmark. Where's the Gaia benchmark, folks? It's a benchmark for general AI assistance that solves a bunch of problems and so on. It's usually used to define that an agent is really good if it does well on this benchmark. The thing is, doing well on benchmarks that are widely available online does not necessarily mean it's going to do well on your tasks, especially because the agents that are being developed right now, especially in research or in enterprise, they're usually kind of tailored to be well on these benchmarks so that they look good when people talk about them in mainstream media and so on. So my advice is make your own vibe check data sets. And I say just vibe check here just to make sure that you understand that it's like develop your own intuition, okay? And there's a bunch of other things that you can check out to evolve on this. Like, for example, SWE Bench is another cool, it's another cool benchmark. So there's a bunch of examples. I think at this point, folks, we're pretty much done. Those are all of the things that I wanted to address. One really good approach that has worked quite well in industry so far, apparently, is LLM as a judge. So that's when you use an LLM, like in the summary example that was using an LLM, you can use an LLM to judge the output of another in order to evolve that approach. And there's like a bunch of resources you can find online on this topic. You can have the LLM rate responses, compare responses, identify problems, and so on. Right? Now, there's a bunch of frameworks that allow you to build agents, folks. Right now, I think that the main ones are LangGraph, Google ADK, OpenAI Agents SDK, Crew AI, Haystack, Pydantic AI. There's a bunch. The understanding all of the things that we've discussed gives you pretty much everything you need in order to, look at these frameworks and say, okay, for my situation, my problem, I think I'm going to go with this framework or that framework. All right, folks. So quickly to discuss frameworks like LangGraph, LangChain, and Crew AI, and Google ADK, OpenAI Agents SDK. There are a bunch of frameworks out there to build agents. And I think that there's a simple way to think about it. The pros of frameworks are faster development, having battle-tested patterns that are pre-built, implemented, ready to go. For example, LangGraph has a pattern for a React agent ready to go, so you can just call that and build your agent. There's strong community support because most of these frameworks are open source, and built-in monitoring. Now, the cons is that every time you use a framework, you have to learn that framework, learn how to build things in that framework. There's also hidden complexity you don't see. Things can break, right? You're locked into this vendor and how that vendor wants you to do things. And there's always the temptation with LangChain was highly criticized about this, but I think with LangGraph, they started to make some improvements. But there's always like the danger of over-engineering and we need to do this very overcomplicated thing. So the recommendation is always to start simple, understand the fundamentals, and then adopt frameworks strategically for your problem, your situation, and so on, right? And in some other videos, in next videos coming up, I want to cover the model context protocol. What kind of problems does this thing tackles? What kind of problems does it solve? Why is it interesting as this interface to help us give access to agents to different tools? But we'll talk about that in the next video. So folks, that's it. Thanks for watching. And don't forget to like and subscribe. Until next time. Cheers.